Moving on in the VSEPR discussion, prediction of molecular shapes and orbital shapes based on Lewis structures. We take a 5 electron pair case, but this time 4 of them are bonding and 1 is non-bonding. And in this regard, we take SF4 as an example, sulfur tetrafluoride. The first step always is to draw a Lewis structure. And in that, we need to calculate the total number of valence electrons in sulfur tetrafluoride. And the valence electrons will be, well, 6 from sulfur, because sulfur is located in group 6A, just like oxygen. It's actually under oxygen in the periodic table. So 6 valence electrons from sulfur. There are 4 fluorine atoms, and each of them contribute with 7 valence electrons, because fluorine, just like the halogens, they are located in group 7A. So each of them has 7 valence electrons. So 28 plus 6, that is 34. So there are 34 valence electrons in this case of sulfur tetrafluoride. If you divide that number by 2, we get 17 electron pairs. So 34 divided by 2, we get 17 electron pairs. And the next step would be to always draw the central atom, which is sulfur. So that's sulfur. And then we draw 4 fluorine atoms around sulfur. So that's 1, that's 2, that's 3, and that's 4. Next step would be to draw a single bond, a bond between the central sulfur atom and each of these fluorine atoms. So that's 1 bond, that's 2, that's 3, and that's 4. Okay? Next step would be to satisfy the octet on surrounding atoms. Each of these fluorine atoms so far is surrounded by 2, and that's not sufficient, because according to the octet rule, they should be surrounded by 8 electrons. So we need to make sure that that's the case. So each of these fluorine atoms will now be surrounded by 8 electrons following the octet rule. So there are 8 electrons around each of these fluorine atoms, and there are 4 of them. If you add that up, you get 32 electrons so far used in this Lewis structure, but we had 34 electrons to start with. So we have 2 to go, and these 2 additional electrons should be drawn on the central sulfur atoms in the form of a lone pair, which suggests that around the central atom, around the sulfur central atom, 4 of the electron pairs are bonding, and 1 of them is non-bonding. To double check, to make sure, or to verify the validity of this structure as a possible Lewis structure, we need to add the number of valence electrons used. Okay, so there are 8 on each of these fluorine atoms, so that's 32 plus 2, that's 34, and that's reasonable because we had 34 before. If you check the electron pairs, you will find there are 4 on each of these fluorine atoms, so 4 by 4, that is 16, and the lone pair on the central atom, so that's an additional 1. So the total number of valence of electron pairs used in this Lewis structure is actually 17, and that's in line with the number that we have found or obtained before. Now, what we need to check is the arrangement of electron pairs, or the orbital shape, in this case of sulfur tetrafluoride. And since there are 5 of them, so the orbital shape or the arrangement of electron pairs around the central atom is still trigonal bipyramidal, because there are 5 of them. So we need to write that down. Well, it's trigonal bipyramidal, but the molecular shape may not be the same, because there is 1 lone pair. So we need to take one of these off, and if we do, the molecular shape is no longer trigonal bipyramidal. This is actually seesaw. It looks like a seesaw or distorted tetrahedron. So the molecular shape is seesaw or distorted tetrahedron. It's no longer trigonal bipyramidal because of the presence of a lone pair around the central atom. So let's write that down. So the molecular shape is seesaw. To conclude, in this case of a 5 electron pair case, 4 of the electron pairs is bonding, 1 of them is non-bonding. The orbital shape or the arrangement of electron pairs is trigonal bipyramidal. The molecular shape, however, is seesaw because of the presence of 1 lone pair around the sulfur central atom.